So what we're looking at today, our objective, again, we're dealing with quadratics. Our objective is we want to transform and describe those effects of those transformations for quadratic functions. So we want to transform and describe the effects on quadratic functions. Now, I am going to be using the Texas notes. You don't necessarily have to. Some of y'all have been. Some of y'all, this is just a guideline to help you take notes, but you can just follow along and write down what I'm writing down. Vocabulary, because there's some good vocabulary here. First one I would start off with is, what is a quadratic function? Quadratic function is a function written with x squared as the highest degree. That means that you could have like an x squared plus an x plus something, or parentheses x plus something, close it, squared, whatever. But you wouldn't have x cubed, x squared, then x, then a number, or x and a number. That's something that's linear. Okay, so we want x. We want to see an x squared. We want to see an x and a square. A parabola is the U-shaped graph formed from a quadratic function. And again, these are things that you've seen before, you've heard about before. The vertex. The vertex is the middle point. It's either the maximum or the minimum. We'll talk about that more in another section. Not today, but we will definitely talk about that more. But always keep in mind that your max or minimum point, your highest or lowest point on the U-shaped graph is going to be your vertex. And it's going to be in the middle. The vertex form is, again, you've seen this before. This is where we do like f of x is equal to a parentheses x plus or minus h, close it, plus or minus k. And again, there should be a square outside the parentheses. I think I forgot to put it on, but it'll be added in a second. And again, remember, the vertex is the opposite of the number inside the parentheses, comma, the number outside the parentheses, to the right. The number that's in the very front is your a. That's what's going to give us the vertical stretch or vertical compression. So make sure, again, this is something we've seen before. Quadratic function to the linear function. Okay, with a linear function, if I chose the x and the f of x, which again is the y, I could put for the x -2, -1, 0, 1, and 2, and for the linear, the y would be the same thing, -2, -1, 0, 1, 2. And it would give me a straight line. But for the quadratic, if I do the -2, -1, 0, 1, 2, I don't get those same numbers. I get 4, 1, 0, 1, and 4. Because -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And you can see the y's repeat. Because of that, it creates what is called a symmetrical graph. Gives me that U-shaped graph that I'm used to seeing. That U-shaped, again, is called a parabola. If you're using the Texas notes, they put H units for the vertical translations. It should be K. That's just the symbol that we use. But let's look at the H. Again, the H is the one that we do inside the parentheses. So it would be like x plus or minus h, close the parentheses, squared. The plus moves it which way? To the left or to the right? To the left. Remember, inside the parentheses, think opposite. So a plus will move it to the left. A positive will move it to the right. Also, and this is where it would be good for having your notes for a quiz or having a note card for the test so that you can have that to remind you. So let's look at an example. X plus 3 squared. What does a plus 3 do? Move it to the left. 3 units to the left. If you do that, that's the graph that you'll see. Goes 1, 2, 3 to the left. That's your vertex. Make your U. There you go. It's a very general graph. I'll talk about how I can be more specific with the points that are here. But for now, that's good enough. The next example, f of x is x, parentheses x minus 2, I think? Yeah, squared. Okay, what does the minus 2 do? 2 to the right. Okay, so I would just go, starting from the center, go 2 to the right, make my u from there, and there you go. For the k, again, it's x squared plus or minus k on the outside. The plus tells me to go up, the minus tells me to go down. Notice there is no parentheses, or if there is a parentheses, it's the number on the outside of the parentheses, to the right of the square. So if I do an example of that, f of x is equal to, I don't even remember, x squared plus 1. That tells me I'm going to go which way? To up 1. Now again, remember, in the parentheses it's opposite. Out of the parentheses it's normal, so a plus will make you think, oh, I'll go up. Up 1, so go up 1 and make that. Hello. Just 1 second. Okay, let me go ahead and erase that. How about if it was minus 4? What does that tell me? Down 4. Okay, so we get that graph. That would say go down 4, 1, 2, 3, 4, and then make your line, or make your U-shaped graph. I have reflection across the y-axis, so I'm ignoring this one. That one we're going to omit, and we're just going to look at the reflection across the x-axis. How do I get a reflection? Just put a negative in front of everything. So it'll be like negative x squared. Okay, if you have a negative at the very beginning, right after the equal sign, that's going to give you a reflection. It's going to make it face down. So that negative gives me the reflection, makes it face down, and you can see in comparison to the parent function, which I have here in red, it's the parent function faces up. A negative, a reflection, makes it face down. That's the only way this will be pointing down, is if there's a negative. Compression. And I'm going to discuss horizontal stretch and vertical, or is it horizontal stretch compression and vertical stretch compression. We're used to the vertical one. We've done it before with absolute value and other things. This one we're not as used to, the horizontal, because I kind of skipped it last time and I didn't want to do it. I'm going to cover it because for those of you that are juniors or sophomores, you'll see it again in pre-calc. And I know that the teacher there, he brought it up. Or he put it in there, so I'm going to make sure I cover it just so y'all see it. I'm not going to put as much emphasis on horizontal as I will vertical, but it will be there. So again, if I have a number in front of the x squared, that's going to be dealing with vertical stretch or compression. Notice there's no parentheses. If the number is bigger than 1, it's a stretch. If it's between 0 and 1, it's a compression. And when I say stretch, I mean like the quadratic graph would look narrower. If I say compression, it would look wider. You stretch away from the x-axis in a vertical stretch. You compress towards the x-axis in a vertical compression. It's a little bit different with the B and the horizontal stretch or compression. First thing you're going to see is it's in parentheses. It's still next to the x, multiplying it, but it's in parentheses. And again, I'm still saying if the b is greater than 1, it's a stretch. If it's between 0 and 1, it's a compression. But those are horizontal. Now, a horizontal stretch actually makes it wider because it's stretching away from the y-axis. A horizontal compression will actually make the graph look narrower because it's stretching towards the y-axis or compressing towards the y-axis. So I would keep that in mind. Also notice how this is 1 over b. So think opposite. And I'll show you that in an example in a second. But again, when we talk about vertical or horizontal stretch, we're stretching away from the y-axis. Whereas in vertical stretch, we're stretching away from the x-axis. This would be where, again, I'd make sure I have my notes on this. I'd make sure I have my note card ready for this when I'm taking the quiz or the test. For example, if I look at this, y equals 3x squared. Okay, 3, notice it's not in parentheses, it's just 3x squared. Okay, what type is, first off, looking at that 3. That's vertical. It's not in parentheses, think vertical. Is that a vertical stretch or a vertical compression? That should be a vertical stretch. And let me get a little bit more specific on the graph for this. Okay, our parent function is y equals x squared. There is a quadratic slope. You'll hear other teachers call that magic numbers, but I like to call it quadratic slope. The standard quadratic slope is 1, 3, and 5. Okay, where this tells you, this top number, this 1, the 3, and the 5 tell you how many go up. I'm going to go from the vertex. I'm going to go up 1, and then I'm going to go to the left and to the right 1. Then from those 2 points, I'm going to go up 3, and to the left and to the right 1. And then from those points, I'm going to go up 5. 1, 2, 3, 4, 5, and to the left, to the right 1. That's your standard quadratic slope. I can connect those points, get my U-shaped graph, and there I go. What you do with a standard quadratic slope, take these numbers, you multiply them by 3. What's 3 times 1? 3 times 1 is? 3 times 3? And 3 times 5? Okay, that's the slope for the graph that we have here, or the equation we have here. So from the vertex, because it's still starting right here at the same point, starting here at 0, 0. From there I'm going to go up how many? Up 3. And then go to the left and to the right 1. So up 1, 2, 3, to the left and to the right 1. Okay. I could try to go up 9, but I think I go off the graph, so I didn't worry about that. And so I just went ahead and connected my points and made my U shape. You need at least 3 points. You need a vertex, and then 1 point on either side of the vertex. Each. Okay, so that's what I had with the yellow one. I had 3 points. I could work with that and go from there. Any questions on that? Again, folks, if you do have questions, send them to me on Edmodo. I generally try to check them. Well, yeah, I check them. Okay. Vertical stretch, vertical compression, that's easy. That shouldn't be a problem. It's the horizontal one. I think that will be more confusing. I'm not going to worry about the graph on that one. I just want y'all to see if y'all can decide. Horizontal stretch, horizontal compression. Here's the key. Think opposite. Okay? And in this sense, this is multiplication. So the opposite in multiplication is reciprocal. So you can see here, notice it's in parentheses. That means I'm dealing with a B. And this is a horizontal stretch or compression. What is the reciprocal of 1/2? 2. So that means your B is 2. Look at that number, not the 1/2. Look at the 2. And then tell me, based on this being a 2, is that a horizontal stretch or horizontal compression? Is that number bigger than 1? Okay, it's a horizontal stretch. That's it. I think that's the best thing you can do is just, it's in parentheses. Again, we're in parentheses. Think opposite. So the opposite of a 1/2 is a 2, and that's the number you're working with. So if that number is a 2, is that a stretch or compression? Stretch. Horizontal stretch. So what's the reciprocal of a 2? 1/2. So that means the B on the second one is 1/2, which is a horizontal what? Compression. There you go. If you can remember that, inside the parentheses, if the number is in front of the x, take the reciprocal. Write it in your note card, write it in your notes. That should make this easy. Good night. Bless you. All right. Any questions on that? Okay, so let me do a couple of examples, and then I'll give you your assignment, and we should hopefully, I think that would be it. Okay, so again, don't forget this is our vertex form. Notice I don't have A and B together in one big format. So generally, if I'm going to give you a B, a horizontal stretch or compression, it's going to be by itself. There won't be an H with it. There won't be a K with it. There won't be a plus or minus A. And it's just going to be in there by itself with the X. Okay, the minus in front of the A means a what? Okay, again, what do I use for down? Let's say that I'm going to point it down. A reflection. Because if I ask you to describe the transformation, you see that negative, tell me reflection. Or at the very worst, face down. Again, plus and minus H, the plus means I go to the what? To the left. A minus goes to the right. Plus K means go up. And a minus means go down. And then don't forget, the A tells me the A number is bigger than 1. It's a vertical stretch. If the number is between 0 and 1, it is a vertical compression. And the vertex is the opposite of whatever number you see inside the parentheses, comma, K. The number that is, whatever that is, whatever sign. So you need to be able to describe the transformations. You need to hopefully tell me the vertex, and then kind of give me a graph. So I said 2 examples, and then I'll give you your assignment and I'll be done. Example, f of x is equal to parentheses x minus 4 squared plus 3. Is there a describe the transform? I want on this. Describe the transformations. Give me the vertex, and then graph it. Okay. Is there any reflection? No. Is there a stretch or compression? No. What does the minus 4 do? Right 4 and the plus 3?
Up.
Okay, so right 4 plus 3, or 4 right, up 3. Okay, so I went 4 to the right and 3 up. That point right there, 4 to the right, 3 up, that's my vertex. Sure. That's going to be my vertex. From there, well, actually, what is my vertex? What point is that? 4, 3, because you went 4 to the right.
Oh.
So my vertex is 4, 3. And again, notice how that's the opposite of this minus 4, comma, K, 3. Then from there, my standard quadratic slope, again, my quadratic slope, normal quadratic slope is 1, 3, 5. Did that change? Was there a number in the front that multiplied that? No. So from here, from this point, the first thing I'm going to do is go up 1, to the left, and to the right 1. Then, from there, up 3, to the left, and to the right 3. I'm sorry, to the left and to the right 1. And in theory, I could go up 5, and then to the left and to the right 1, but I'd run out of space. So I'll just connect those points and make my graph. Any questions on that? Okay, this one, it's f of x is equal to negative, it should be negative 2, parentheses x plus 3 squared minus 1. Forgot the negative, I added it at the end.
Negative 2?
It's negative 2, yeah. All right. Okay, face down or reflection. The 2 would be, it's a stretch or compression? It's a stretch. And more specifically, it's a vertical stretch. Okay? And then the plus 3 tells me to go which direction? 3 to the left and 1 down. So this is a vertical reflection, vertical stretch, 3 to the left, or left 3, 1 down. Or down 1. Okay. Now, the reflection and the stretch do nothing to finding the vertex. If I go 3 to the left and down 1, that's the point, that's my vertex. That's my middle point. And in this case, my max. And so I can say my vertex is -3, comma, -1. My quadratic slope, again, is normally 1, 3, and 5. But let's keep in mind here, what am I going to do with that -2? I need to take that -2 and multiply it to this 1, 3, and 5. What's -2 times 1? What's -2 times 3? And -2 times 10, I'm 5, -10. All right, that tells you how much you need to go down from the vertex. From the vertex, you're first going to go down, according to that, down 2. So from here you would go down 2, and to the left and to the right 1. Then from there you could go down 6 from those points. I think I'd run out of space to do that, so I'll just go ahead and graph the points from there, connect those dots, make my U shape, and there you go. Okay. Now again, this is something that should be pretty easy. If you practice with it, with the assignment that you have, it won't be hard at all. Any questions? Okay. Your assignment is the Practice B workbook, all of them. There's only like 6 problems on there. And then from the textbook, I think it's on page 320, problems 5 through 15, and 29 and 30. All of those are describe the transformations, tell me like where's the vertex, and that's about it. There's, I think, the last 4 on there, they'll ask you, here's the transformations, can you go backwards and give me the equation, the function? But the first few are, here's the function, give me the transformations. Okay? If you have any questions, feel free to ask. Otherwise, there's your assignment. Yes, ma'am?